Hi, this is Dr. Hassan Abdullah with the course Complexity Analysis of Algorithms. The topic in this video being covered is dynamic programming, and the subtopic is basics. So, as per our course outline, this is topic number 7, and this is 7A. So, the first subtopic of the topic 7. This course is supplemented by the material at easymcq.com/goget, and this is basically a learning management system. To be very precise, this is a personalized learning management system, and what it does, it allows you to personalize your route to learning or your route to learning. And how you do that, it's shown in this video. And then of course you can also personalize how the interface, color and font appear to you, so that you get the most of it. How you do that, that's video number 4. And you can also have a personalized testing and evaluation of what you've learned, and which includes online testing, grading, and analysis of overall results. How you do that, that's in video 5. And multi-level format of the questions, answers, bullets, descriptions. Uh, you have menus within menus to save space and simultaneously search advanced and basic. How you do that, that's video 2 and 3. So these videos to how to use this tool, they are available on my YouTube channel along with the videos of the courses and the lectures. So just go to YouTube, type my name, Dr. San Abdullah, and you will get access to all those videos. Okay, so we'll move on to the course topics which are covered in this course. So this course consists of 11 topics, and the topic which we are covering in this lecture and subsequent lectures is dynamic programming. And I will also cover advanced algorithms. I will spend some time on randomized algorithms, approximate algorithms, and genetic algorithms. So let's move on to the supplemental website now. So we are at the supplemental website, and we have different courses here. We have analysis of algorithms, and we have other core computer science course, data structures, algorithms, and generic programming, natural language processing, and other hot topics and courses. But our focus is on the course of our interest, which is analysis of algorithms. We go to analysis of algorithms, and the topic of our interest is dynamic programming. So I click on dynamic programming. All right. So now we will discuss the basics of dynamic programming. So what is dynamic programming, and explain using the constituent parts which constitutes dynamic programming. So let's click and view the answer. So we have these bullets. So what we will cover in this answer is the definition of dynamic programming, how we define it, and what is the optimal substructure, and which ensures, along with the greedy choice property, if the grid is used, that how and why dynamic programming works. And the actual thing which differentiates dynamic programming with from other techniques is the overlapping subproblems, which cut down on the repetitive tasks. And then there are two approaches of storing the results, which is one is memorization, the other is tabulation. We'll talk about them. So let's look at the description. So this was view the answer as bullets, and then let's look at the description, view the description. So these bullets can be very helpful when you are preparing for your final exam or your mid exam. Okay, so what is the description of dynamic programming? Breaking problem into smaller subproblem, then solving the subproblem, each solving the subproblem once. Okay, storing the solution and using these solutions to construct the optimal solution of the entire problem. Okay, so this is like making use of the work done prior. For example, Fibonacci sequence problem, dynamic programming avoids redundant calculations by storing already computed Fibonacci numbers and reusing them. So this reuse reduces the overwork. Optimal substructure, the solution can be constructed, optimal solution can be constructed from optimal solutions to the subproblem. So this property is used by dynamic programming by recursively solving the subproblem and combining the solution. For example, 0-1 knapsack problem has optimal substructure, okay, right, where the optimal solution for a knapsack of capacity W can be derived from the optimal solution to the subproblem. Okay, so but that was not the case. 0-1 knapsack is not solvable using the greedy approach. Okay, fractional can be done. Overlapping subproblems. So what is the description of the overlapping subproblems? Overlapping subproblems occur when the same problem is solved multiple times. Same problem solved multiple times. So why don't there's no point in doing it again and again. Okay. So what dynamic programming does is problem is solved once, storing a solution, okay, and preventing the redundant calculation. So that takes care of the time complexity also. So for the Fibonacci sequence, the sub problem of calculating Fibonacci n minus 1 appears many times. Okay. And of course, dynamic programming uses these results which are stored and reused. So what is memoization? What is tabulation? Memoization is a top-down approach. Problems are solved recursively, and the results of subproblems are stored in a table or a cache. So whenever the problem is encountered again, its result is retrieved from the table, retrieved rather than being recalculated. So example is like for Fibonacci numbers, memoization stores intermediate results. So if Fibonacci n is needed again, the result is directly fetched from the table, reducing the time complexity, reducing. So there's no need to redo it. And the tabulation or the bottom approach, subproblems are solved iteratively. So solved iteratively versus solved recursively. So let me highlight this. Solved recursively and solved iteratively. Okay. All right. So and shown in a table. So the final solution is derived by building up from the smaller subproblems. Okay. So this method eliminates recursion. So for Fibonacci, the bottom approach starts with Fibonacci 0, then Fibonacci 1, and so on. So iterative approach. Iterative approach has its own advantages because recursion can result into stack overflow and memory issues and performance issues also. All right, so we'll move ahead. Okay, so what is the significance or meaning of the word programming? So what is programming in dynamic programming? What is this? So view the answer. So we have these bullets. So meaning of the word programming in the context of dynamic programming. So programming is a problem solving strategy, okay, and which takes into account the optimization and how does it works, breaking down the problems efficiently and solving the overlapping subproblems. So historically it is called as programming. It is more of a bookkeeping, but it is called programming anyway. So what is the meaning of programming in the context of dynamic programming? Okay, it is the systematic process of solving a problem by breaking it down into subproblems and using the stored solutions to optimize overall performance by not redoing them. So what else programming covers is a structured approach to solve the complex problem, okay, by recursively solving the subproblem, storing results. So that is the, as per the previous example, you know what is, it's a bottom up or top down approach. What else is programming? Emphasizing optimizing the solutions. So the goal is to find the best solution to a problem by efficiently combining solutions or the subproblems, solution to the subproblem, reducing the redundant computations. And of course, when the number of computations are reduced, the overall time complexity also reduces. This programming also reflects the decomposition of the problem into manageable smaller parts. So what happens is that large problems are more efficiently solved, okay, when they are overlapping subproblems. And historically, programming is referred to the planning or scheduling of tasks. So that is not emphasizing that you must do coding or as part of dynamic programming. That is not the case. So the idea is efficient approach to solving a problem. Programming is like taking care, making things manageable, and having a schedule and everything. So that's the meaning of programming here. It's not the literal meaning. So what is meant by bookkeeping in dynamic programming? Storing the results of subproblems so that they can be retrieved efficiently. And tracking the state transactions, I will talk about it. Efficient storage structure. Efficient means that the storage is also effective and the retrieval is also effective. And backtracking for reconstructing the solutions. So backtrack and then reconstruct the solution. I will go into details. And minimizing redundant calculations. How? Because of overlapping subproblems. Okay. So these intermediate subproblems are stored in a table or an array. Okay. Why? Because then you can access them efficiently. Number one, reuse efficiently and avoid redundant calculation. No need to do things again and again. Okay, now tracking the state of subproblems, bookkeeping helps in recording how one subproblem transitions into another so that the sub solution which was already saved, it is used in a proper order. And how it is stored, it can be stored using arrays or matrices or hash tables. The benefit of this is that they can provide you a constant access time. So what is the benefit? Optimizing both the memory, okay, because linked list will have additional memory, and access time, order one constant time access. Backtracking for reconstructing solutions. In dynamic programming, bookkeeping involves keeping track of decisions made at each step. And when the backtracking is done, then we reconstruct the optimal solution. And minimizing redundant calculations that have been said enough times. Okay, so how does top-down approach works in dynamic programming? So this is recursive function, okay, and the bottom-up approach is tabulation is iterative. So this is the beauty of this approach of presenting that you can look at the bullets, okay, at the same time, and it's very good and very efficient comparison. So this is top-down is recursive, bottom-up is iterative, okay, and example is Fibonacci series for both of them, and they avoid it avoids the redundant calculations by recursion, and this avoids by using the dynamic programming table. So let's look at the details of question number 4. So what happens in top-down approach is the problem is solved recursively, okay, and memorization is used to store the results of these subproblems to avoid redundant calculations. So when a subproblem is encountered, stored result is retrieved instead of recalculating. So when we are looking for Fibonacci n, okay, so we look at the Fibonacci n minus 1 or Fibonacci n minus 2 is encountered. So we look at how it was calculated, and so it is only done once. So memorization store the results of previously computed subproblems in a data structure, array or dictionary. Dictionary is hash table to be reused, not to be recalculated. So that every problem is solved only once. Solved only once. So when calculating Fibonacci 5, okay, once we need 4 and 3 are calculated, and then we calculate 4 and 3. So when we need it again, we don't need to calculate, we just refer back to the calculation. Avoiding the redundant calculations, avoid solving the same subproblem multiple times by using memorization. So the subproblem is computed once and the result is reused, which optimizes the time complexity. Of course, the answer remains the same. So we have already done this example of Fibonacci sequences. So let's look at the bottom-up approach, which is iterative process. So in the bottom-up approach, using a tabulation method to solve the problems iteratively. So iteratively is the keyword here. So instead of using recursively, we use iterative approach, okay, and stored in a usually in an array, right? So start calculating Fibonacci 0 and Fibonacci 1, then iteratively compute Fibonacci n instead of doing it recursively. And how we do that? Building upon previously computed values. Iterative process, this bottom up eliminates the need for recursion by using the iterative loop, all right? And the advantage is in both memory and usage and time complexity, because you need stack space for implementing recursion and many pushes and pops that takes time. So filling the dynamic programming table is populated with values starting from the smallest subproblem and working towards the final solution. So each table entry depends upon the previously filled entries. So ensuring that once a problem is solved, it is readily available, okay, for the Fibonacci case in front of us. So the bottom approach is highly efficient for computing Fibonacci numbers because it fills in a table of value Fibonacci 0 to Fibonacci n, okay, in a single pass. So the optimal complexity is order n with space complexity order n also, okay. So that's all for this topic and subtopic. Now we'll move to the second subtopic. Thank you.